Thanks. Hi, everyone. My name's Andy. I want to talk to you today about the readability of our code and why it's important, especially our craftsmanship, and especially with AI tools coming in, why it's still really important that we care about things like this. And to do that, I'm going to use two literary classics as an analogy. James Joyce's Ulysses and Eric Carle's The Very Hungry Caterpillar. For those who don't know me, my name's Andy Carter. I am a technical team lead at Evoluted, which is a digital agency based here in Sheffield. That's not good because it's going off, right? I'm not a .NET developer, we're PHP developers where I work, but this is very much a language agnostic talk. Some of you may have heard of me through my hobby project, which is Street Art Sheffield. So I go around documenting and mapping out the Sheffield street art. So you might have spotted me doing tours around the city with a group of people following me around looking at murals, but that's me. A lot of the time when we think about what we do as developers, software engineers, however you want to call the role, if you describe what you do for your living, most people will say that they spend their time writing code. Maybe some will say that they also problem solve, hopefully, because that's often a key part of our work. But rarely do people say that they spend their day reading code, and yet that is what we spend the majority of our time doing. Robert C. Martin, who has written a number of books about quality of code, said that the ratio of time spent reading versus writing is well over 10-1. Now, it kind of makes sense that we put the emphasis on the writing code because that's where our deliverables come from. But it's really important for us to be aware that we're actually spending most of our time reading the code, not writing it, because if we understand that, then we'll understand the importance of making sure that our code is readable, because what we don't want to do is actually spending significantly more time reading the code than writing it because we don't understand the code that we've got in front of us. So before we start looking at the analogy of Ulysses and the Hungry Caterpillar for our code, just want to address who's actually reading our code other than ourselves, who's interacting with it, who's trying to understand it. So to do that, I'm going to introduce 4 different developers as examples of the type of people reading our code. So first up, we've got the less experienced developer. Now, I've depicted them here as someone who's very youthful looking, but I don't necessarily mean someone that's a junior developer when I say less experienced. Even a senior developer can be less experienced. Depends on what they're working with. You could have a code base, a project you've never seen before in front of you. At that point, you're less experienced. It could be in a language or a framework you've never worked with. Again, you become less experienced. So how well written that code is makes a big difference to how quickly you can start to get on board and understand what you're looking at. Second developer is the code reviewer. So again, this is probably someone who's less experienced in the sense that they might not have worked on that project before, but they're reviewing the code. Where I work, that often happens. You could also, the obvious part of it is that you won't be familiar with the code you're reviewing because you're reviewing somebody else's work. And to add to that, you're often reviewing out of context of the whole overall code base. You tend to be just looking at individual lines of code isolated from their surroundings, just the bits that are being committed as the changes that you're reviewing. So how well written individual lines are makes a big difference to how easy it is to understand what's being changed and how effective your code review is. Next up, we've got the stressed developer. I'm sure most of us are familiar with this. It might be someone who's trying to understand some code to try and find a bug, and maybe the fix is super critical, it was needed yesterday. You're really stressed out. And in that situation, the brain doesn't work at its best. It becomes a lot harder for us to focus and concentrate when we're stressed. And that's really going to impact how we're interacting with the code we're looking at. So the better it's written, the more understandable it is, the easier it's going to be for us to deal with it when we're in that stress situation that is sadly inevitable with the type of work we do. And then finally, I've got the interrupted developer. Now, this could be someone that's working in an office and their colleagues keep coming over and asking them questions, or you could be a remote worker where your phone's ringing or someone's knocking at the door because yet another Amazon delivery's turned up that you forgot you'd ordered. And each time you're interrupted, it's around 15 minutes to half an hour takes for you to get back to full productivity. And that's quite significant in terms of the day that we work. You know, every time you're interrupted, you've got half an hour to get back up to where you were before that interruption. So if you're trying to read code, the better it's written, the easier it is to understand. That time to get back into the flow of things is going to be reduced. So as I go through like looking at the readability of code, I want you to kind of bear these sort of people in mind, because these are the people that are interacting with the code that we write. So I'm going to start with James Joyce's Ulysses. Can I get a show of hands? How many people in the room have actually read this book? Not one person. That's really good news, because I don't have to stand here and feel like an imposter, because I have never read this book myself. I chose it because it's notorious for being difficult to read. Most people that pick this book up and attempt to read it apparently never finish it because it's just so hard to follow. Joyce himself said that he put in so many enigmas and puzzles that it will keep the professors busy for centuries arguing over what I meant, and that's the only way of ensuring one's immortality. If you've got someone on your team writing code like that, I think alarm bells should be sounding, because that's definitely not what you want. But aside from the enigmas and puzzles, just want to kind of think about a couple of the ways that he wrote his novel that make it a challenge to read. So we've got this idea of a stream of consciousness and a shifting narrative style. So stream of consciousness is this idea that Joyce would write in a very literal way the character's thought processes. So in literature, it's not uncommon for an author to write a character's thoughts, but they tend to do it in a very nice, structured way. So nice, simple sentences that are very focused. That is not the way that our brains work. When we think, we kind of go off on very long-winded thought processes. We go off on tangents, diversions. Joyce tried to represent that by writing this idea of a stream of consciousness. So very long-winded sentences, perhaps lacking in punctuation, not really focused, going off on all sorts of tangents. This is very difficult when you're reading. Like, it's not easy to follow. I've seen examples of it from the book, and yeah, you quite quickly lose where you are when you're reading through it. He also had this shifting narrative style. So again, not uncommon to other books, but he would write from different characters' perspectives. But rather than just writing from different character perspectives, like many other authors, he'd also use this idea of shifting the narrative style between the chapters as well. And this results in a novel that doesn't have like a natural flow that we would normally get when reading books. It causes a lot of context switching, and just adds to the complexity of reading the text. So some of these ideas might sound familiar to things you've seen in code. So sometimes you'll find code that's very long, deeply nested. This is very much like that stream of consciousness idea. This sort of, the ideas are just being typed up into the code without kind of stopping to think, how does this actually read back? How does it flow? Is it easy to follow? And then we've also got like this inconsistent styles and naming conventions in code where we're not following any conventions and it's just a bit of a mishmash of different people's ways of writing. And this, again, much like Joyce's novel, creates this context switching problem, which just makes the code not flow. It kind of then causes the brain to trip up as it's reading through things. So these all add to this problem of like a cognitive load. This is what makes it difficult to read. Now, the brain's amazing. The brain can hold vast amounts of information, memories, thoughts, ideas. But when we're reading, we are using just our short-term memory, and our short-term memory is really, really limited. So the average healthy brain can remember between 4 to 7 items every 30 seconds. That's not a lot. And so when you've got really long, deeply nested code that's not focused, you're going to start hitting problems when you're reading through the code. You're going to sort of start to lose where you are as you're reading through. It's a bit like if you were walking through a forest and leaving a trail of breadcrumbs behind you so you could find your way back, only to turn around and discover that the wind's blown some of the crumbs away, birds have eaten others, and you suddenly discover you're really disorientated. That's essentially what's happening when we're faced with code that's kind of directionless, deeply nested, really long. And then this idea of the context switching, the reason this is problematic is it causes mental fatigue. The brain's ability to focus is impaired because it's having to keep swapping, like the style and the consistency not being there. It just makes it really hard to follow. And as a result, we're more likely to make mistakes, more likely to misunderstand what we're reading. So if we want our code to be readable, we need to look at ways that we can really reduce that cognitive load. So that brings me to Eric Carle's The Very Hungry Caterpillar. So can I get a show of hands who's read this book? Like, significantly more. And I can say I have read this book. It's the only book I read for the preparation for this talk. I thought I'd make sure I had read at least one of them. It's not a surprise that many more of you read it. And it's not just because it's a children's book, because Ulysses is an adult's book and we're all adults in the room. So that's not the excuse. It's the fact that it's written in such an accessible way and it tells a story that's very clear, easy to follow, that means it's a book that so many people will pick up and read, and why it's so popular. So again, just like as with Ulysses, I'm going to pick up on a couple of reasons why Eric Carle's book is so easy to read. So he used a very simple and repetitive structure. As you go through the book, there's a lot of familiarity as you turn in the page. There's a repetition in there that makes it really easy to follow the story. And he also used very consistent and explicit language. And by explicit language, I don't mean that we've got a really sweary caterpillar. What I mean is that Carle used words that were very descriptive. He didn't use ambiguous words. He made sure that he used words that described exactly what he meant. And these are things that we can see in code, in readable code. We can use small, focused functions and build in a logical and predictable flow. So that's kind of building on that simple, repetitive structure that Eric Carle used in his novel. And we can also use consistent naming and styling, making sure our variables have got sensible names that describe exactly what they're doing, removing any ambiguity. So these things, they all really reduce that cognitive load. They make it easier to read, easier to understand. Now, you might have been thinking, when I was talking about the fact when we read, we're using our short-term memory, you might have thought 4 to 7 items every 30 seconds. I can remember way more than that. I hate to break it to you, but you're probably not a superhuman. It's more likely that your brain is utilizing concepts like chunking, where essentially what it does is it's seeking out patterns, because our brains really, really love patterns. And when it finds those patterns, what it's doing is it's grouping ideas together. And it's those groupings, those like categorization of things that your brain's remembering in that short-term memory. So it's kind of like a cheat's way of remembering more things. And then also we've got this idea of recognition over recall. So that repetition is kind of building in this structure that we can see, we can recognize it, rather than having to kind of really think about what's happening. We can kind of then just scan through the code because there's that familiarity built in. It's a bit like we can use muscle memory. So I try and play the guitar. I'm not going to say I'm great at it, but one of the things you learn when you start playing guitar is to use muscle memory, because you can't possibly be trying to play a chord in your left hand and strumming it in your right hand at the same time. If you have to kind of stop and think each time about what you're doing, you have to kind of reach this point where they just become natural to you, and you just start naturally just doing it without thinking. Your brain just does it. It's this muscle memory idea. And while we don't have quite the same concept with like when we're reading, there's the similarity with that idea of that repetition, that familiarity stops us having to really stop and think deeply every time we come across things. So we kind of want to be making sure that when we write code that we're utilizing these ideas, because the problem with bad code that's written in a way that's difficult to read, is that it introduces more bugs, insecurities. It's much harder for us to maintain. And as a result, we're much less productive, because we're going to spend significantly more time trying to understand what is going on when we're looking back at it. This brings me on to legacy code, because it's one area that most developers that I've worked with, if you ask them what it is they're working on that day that's really causing them so much grief, why are they not happy, they'll usually say, well, it's because I've been put on some legacy code today, I'm trying to work through it, and I'm just really stuck, I'm really struggling. And I kind of think that we're at risk now that we're taking on new tools as developers using AI, that we're kind of risking creating a new form of legacy code. And I think it's important we're aware of that, and that we're reminded of why we need to be writing clean code, because that still applies with AI becoming a thing, if not more so. And we need to recognize that, we're creators, we have this skill that we should be crafting really good quality code. So legacy code is a bit like if you pick up a copy of Ulysses, pick a random chapter, and then just randomly halfway through it, try and start reading. You're just going to be completely lost. You're not going to have a clue what's going on. And it really doesn't help that it's this challenging read in the first place. If we're going to try and define legacy code, we usually say that it's old. It's probably no longer actively being maintained. There's a good chance that the original author developer has left the business, or if they still work there, they're busy on something else, and most likely have completely forgotten what they wrote in the first place, so no help anyway. And also, the code's likely to be messy. It's difficult to read, difficult to understand. And for me, it's that last point that's the important one. It's not that it's old. It's not that it's no longer actively maintained or the author of the original code is gone. It's the fact that the code is difficult to understand. That's what makes it legacy code, because I've worked with code that's old. I've got colleagues who've worked with code that's old, and they've said it's a pleasure, and that's because that bit of code was really well written. It's still easy to follow. It's still easy to understand. It's when they hit the code that was written without the readability of that code taken into account that they start to hit those problems. One of the reasons that I started to think about this as a talk earlier in the year was a colleague of mine had approached me. They were trying to fix a bug. They were trying to find a bug in some code that they had in front of them, and they were really struggling. So they asked if they could pair up with me. And I got them to start talking through the code they were looking at, try to explain what was going on bit by bit. And the code was so deeply nested, it became apparent really quickly that they were getting completely lost and disorientated. They could not follow what was going on. And essentially they had legacy code in front of them, except it was written 2 weeks ago before and by that person themselves. So, they were experiencing that problem that we get with legacy code, but it wasn't because it was legacy, because it was old, no longer maintained or anything like that. It was just because the code had not been written with readability in mind. It worked very much like that Ulysses stream of consciousness idea of just the ideas put out there. And all it took was for us to refactor the code a bit, remove that deep nesting, get it a bit more linear. And then very quickly the bug fell out. It's like, there's the bug, we could spot it. But it needed us to do that refactoring to get it into a point where the code read in a way that was much simpler, easier to understand and follow. So I believe that AI is a big risk that it's going to create similar problems, going to create this legacy code problem. And I'm not here to judge people using AI. I think some people use it, some don't. I know there's all sorts of questions over the ethics and everything else about it. But I think we need to be aware of where our AI sits in the work we do, because it's obviously becoming a much bigger thing. And I know some businesses are now almost expecting their workforce to use it. But I do truly believe that developers knowing and understanding code is still super important, and I don't see our roles disappearing anytime soon. I think we're as important as we've ever been. I want to just draw a distinction between vibe coding and AI-assisted engineering. Vibe coding is a term you might have heard. It's kind of one of those things that's really come about in the last few months. It was coined earlier this year. It is not the same thing as AI-assisted engineering. When we talk about vibe coding, what we're talking about is telling an AI engine to just generate an entire application for us, generate an entire code base. You don't have to be a developer, you can just be anyone. The idea is you get it to generate code, you run the code. You never look at the code, you never understand it. AI-assisted engineering is different. This is a bit more like using autocorrect or predictive text. It's that idea that you're very much in the driver's seat, very much in control, and you're interacting with it and working with it. And that's kind of where I think our industry is kind of going to sit, because vibe coding is not really going to produce products that meet our requirements. But this chart's not based on any scientific data. It's just there to kind of illustrate the point that the more we use AI to do things, then the lower understanding is going to be of what it's generated. So if you're like taking the top here, when completely using AI, then our understanding should be 0 because we're not looking at the code. So we don't understand, you can't understand code that you've never seen. Whereas the more we interact with AI and do it ourselves, then hopefully our understanding should be better because we're more in control, we're following it. But it's really important that we're using AI as an early draft. I'm not going to say first draft, early draft, because I don't think it's even got to that first draft stage. We need to be verifying what the AI is generating and then making sure that it's in a format that's really easy for us to work with going forward, because we're still the people working with the code at the end of the day. AI code is definitely not production ready until we've interacted with it. And so it's so important that the code is still really readable. So like James Joyce and Eric Cole, we as developers, software engineers, we are creatives. And it's really important to think of ourselves in that way, because I don't think we always view ourselves as creatives. But I believe that's what we do. We have all sorts of freedoms to write code in any way we want, using any languages we want. We are creative people. We're coming up with creative ideas to solve problems. And it's also important that we realize that we're writing code for humans, not machines. So yes, we write code that runs on machines, but we don't write code for the machine. If we were to do that, we'd be writing it in machine language straight away. We wouldn't bother with programming languages. We use programming languages because we want code that's in a format that we as humans can actually understand and follow. And we're using AI to generate that code. So we're generating it for ourselves still, regardless of how we do it. And when we're writing code and we're writing it for humans, it's important to remember those different people that are interacting with that code itself. These are the people we need to make sure it's understandable by. So I want to kind of leave you with this idea that if you're writing code, that it's important to make sure it's understandable. And so for that, we need to be a bit more caterpillar in the way we write it. We need to make sure that we keep functions small and focused and avoid deep nesting. We don't want to be writing code that represents that Ulysses stream of consciousness. We need to make sure that, yes, we can put our ideas down, but we need to make sure that we're editing it and making it into a nice, easy to understand structure afterwards. We want to make sure that we're using meaningful names. So I so often see developers use variable names that are just so ambiguous, like data or results, when actually what they're going to store in that variable might be something like products or users. Just call it products if it's going to store products. Don't call it data. It doesn't mean anything. If you're that code reviewer and you're seeing the isolated line of code and you're reading that back, that variable's got no meaning if you can't see it in this context. So we should be using descriptive names like Eric Carle did in his book. And similarly, we should avoid using magic numbers that just appear in code. It's much better to use constants or variables that will describe them, because numbers again are quite meaningless when they're out of context. And then we want to maintain consistent styling, can follow consistent design patterns. So these things, they're what help build that repetition, that familiarity. We often say do not repeat yourself as developers, but we do want to repeat ourselves when it's like the actual overall structure of the code base, because that's the familiarity we need to make scanning code, reading through it easier to cope with. What we really don't want to do is write code like Ulysses. So I said that many people, acknowledge that most people haven't read Ulysses. It's a really hard book to read. No one in this room's read it. A lot of people who will go and read it these days, rather than go and pick up an original copy of the book, will buy an annotated version. An annotated version is basically one that has footnotes, side notes, that are explaining what's going on in the story. Because it's so hard to follow, you kind of need those clues. And we can do the same thing with code. We can use comments. We can fill our code with comments. But we notice there's a code smell. It's not great. Code should really be quite descriptive. It should be easy to follow, explain what's going on. We should only really be using comments to explain the business logic, the bits that are hard to explain in code without going to really ridiculous function and variable names that read like essays themselves. The comments are there for the business logic. We need the code to speak for itself otherwise. What we really don't want to do is end up with comments like this. So this is a comment that I've seen in a genuine code base that I've worked on. Someone put, when I wrote this, only God and I understood what I was doing. Now God only knows. So, yeah, so often I see code that people have had to comment and annotate afterwards because they just don't understand what's going on, or they've figured it out and they just need to comment to try and understand it. But we shouldn't be doing that. We should be using our creativity, our craftsmanship to make sure that the code reads in a really fluent, easy to understand way to begin with. And if we are using AI, it's still really important that we take that on board, if not more so, because we need to be in control of the code itself. So, thank you. Has anyone got any questions? Yes.
I'll take devil's advocate here. So some of the things you kind of mentioned in there on the last few slides, the short functions, clear variable naming, that kind of thing. Like, to what extent do you think that good prompting and good like AI engineering can take care of itself in that sense?
In terms of making sure it's readable.
Yeah. So do you think there's a point where a good engineer with good prompt could produce good clear code and in effect remove himself from having to kind of cognitively do that?
From my experience of what I've seen AI doing, I don't think it's quite there. I think the problem with AI is if you want it to be doing that, you have to put a lot of effort in. Like, you have to feed the prompts so much information. I'm not 100% convinced it's worth putting that level of effort in. I think it's better for us to keep building on our own skills as developers. And then when if we are going to use AI, use it to generate that initial draft and then tailor it. Because the problem is if you get a result and it's not quite right and you prompt it again and say, well, I want you to clean it up a bit, like the functions are too long. It's all probabilistic the way it's working. So every time you do that, you're risking introducing new problems. So I think, yeah, I would say using AI as that initial bit's fine. But I think it's still very much we need to be in control and the ones modifying the result. Does that?
Yeah, so thank you, Andy.
Yes. I had a question. You said small focused functions and avoid deeply nested.
Yeah.
What I have worked with legacy code, usually having small functions or like having interfaces that creates the nested code. And yeah, kind of question, well, where is that middle ground of the small nested? And for example, when you read a book better reads if you read one page, but sometimes with these small functions, you read a paragraph, then you read another paragraph, another page, and you go back. So why is the focus in our work like keeping the functions small?
I've kind of described it as small functions in that when our functions are small, if they're very focused on doing one thing and doing one thing right, it often means that when you're reading through the code, you might see a function call happening, but you're not having to go and see what that function's doing because you know it's doing that one thing. If that makes sense.
Yeah, I think that's the key. If the function that you're calling is named correctly and only does that function, you can read that code knowing that that line does everything that function says it's going to do. Because I sometimes find out that you feel like you're nesting, but if you trust the next stage of the nest, it sort of doesn't matter so much.
I've unfortunately worked with code where people have gone multiple thousands lines long functions, and when you start hitting that, it's definitely problematic.
Yeah, I feel like
but
just in the clean code they say keep functions to 5 lines. It's almost like these extreme rules and just
there's one I've worked with where it was like suggested that functions should never go over 100 lines. Like 5 lines is very short. 100's better. That is somewhat arbitrary. I think the main thing is it's that it does one thing and does one thing well. That's the important bit, and that the naming's right.
Did you have a question?
Yeah, a question. So you mentioned context a couple of times. Obviously, when you're dealing with AI and the context is too big, it will literally tell you that the context is too big. So when dealing with people, how do we determine how much is too much for them to deal with at any one time?
Good question. I mean, the context switching I was applying there, it's kind of the when there's not that familiarity in the code. So if a design pattern's not used, or even as trivial as like coding styles, like where like opening and closing braces are being located and things like that, it can seem really trivial when people pick up on it, but actually it can make quite a big difference because as you're reading the code, if there's not that consistency, your brain's going to start picking up on those and then get tripped up. So I think that that's partly where I was coming up from that. And then when we're not using design patterns again, it's like you're not seeing that familiarity, that repetition's missing. So the context switching is that constantly trying to figure out how different bits are working, as opposed to just being familiar with the overall.
Familiarity rather than necessarily the overall volume of code.
Yeah.